Hey guys, Mr. Barnes here again, bringing another math video. This one on solving exponential equations using logs. So I've got an exponential equation here, and the first thing you need to notice really about this equation is that you do not have the same basis. So I have a base 4 here, and I have a base 3. So if you don't have the same basis, or you're unable to make a common base, like sometimes you might have a situation like you have 4, and then you have 16. And you might have some, exponents on these. I'll just use the same ones I got here. Whoops. Did it again. And you can make a common base because you can write, 4 can stay the same and 16 can change to 4 to the 2. So, you can easily write a common base. But when you don't have that situation, we have to rely on our log rules. So, generally what I like to do, if I have an exponential equation like this, I like to take the log of both sides. So I'll go log of 4 to the 2x, and that's equal to log of 3 to the x minus 1. So you could also use ln if you wanted to. So now that I have that, I have to use one of my rules of logs. And the rule is that if I have an exponent, like I have here, that guy can come right out in front. So the same thing with this guy. This can multiply our log function. Really, really useful rule, and it makes solving these guys so much easier. So I'll end up with 2 times x log of 4. Now remember, log of 4 is just a number. I can throw that on my calculator and get the decimal approximation. And then I'll take this guy out in front, x minus 1 log of 3. Make sure you use the brackets there because that x minus 1, that's all multiplied by log of 3. Now, it all depends on solving this guy. Kind of depends on what kind of answer you're looking for. So I'm going to assume that you're looking for an exact answer. So if you're not looking for an exact answer, if you're looking for an approximate answer, then right now you can change all these logs to decimals. But I'm not going to do that. I'm going to leave this as an exact answer. So what I have to do now is I'm going to distribute through with this guy. So I'm going to go with this guy over here. So I'm going to multiply log of 3 by both of these. So I have 2x log of 4 is equal to x log of 3 minus log of 3. Whoops. I forgot my 3. So now I want to get my x's on one side. So I'm going to basically take this and subtract it from both sides. I'm not going to write it, but I'll subtract x log of 3 from both sides. So I end up getting this. 2x log of 4 minus x log of 3 is equal to negative log of 3. So when I subtract x log, x log of 3 here, and then x log of 3, I end up canceling these two guys. So that's why it happens. So now you can see I have x here by itself. So I can factor that x out. So I'm left with x comes outside the brackets because I got an x here and an x here. And then I'm left with 2 log 4 minus log of 3 is equal to negative log of 3. So now I'm just going to flick to the next page here, so I have a bit more space. So I'll rewrite that step. X 2 log, and that's 4 minus log of 3. And that's equal to negative log of 3. So what I can do now is I can actually divide both sides by 2 log 4 minus log 3. And that leaves me with x is equal to negative log, all divided by 2 log 4, little guy's waking up if you can hear him, 2 log 4 minus log 3. So just in time, and I almost forgot my log 3 on top here. So negative log 3 divided by 2 log 4 minus log 3. So I'm going to have to fetch him from the crib there, guys. So I hope this video helped, and I'll see you guys in class. Thank you very much.